Okay, hello everyone. Thank you for joining, especially those of you who are joining from the other side of the world, and it is very late for you. I really appreciate it, and welcome to everyone who is watching this as a recording online afterwards. My name is Kyle Demes, and I'm a consultant that specializes in research assessment and evaluation, and I've been working with OpenAlex, and I'm joined here by my colleague Jason Portenoy, who is a senior data engineer for OpenAlex that is focusing a lot also on user engagement and outreach.
Hi, everyone.
I'm going to be doing most of the presentation today, but Jason's going to be here to help manage the Q&A depending upon how that goes during the presentation, but also answer a lot of the technical questions afterwards. So just a quick reminder for those of you who are new here, this is the very first of our OpenAlex user webinars, the new monthly series that is starting. The idea here is that people have been using OpenAlex for a year and a half or so around the world, but really only people with advanced data analytic capabilities who are able to access it through APIs. We're going to start rolling out a web-based user interface so that anyone can access it. And the point of these webinars is to really start bringing those people in so that OpenAlex is accessible for everyday research intelligence and assessment needs. So stay tuned. There's one of these every month. Today's is really an introduction to OpenAlex. So we'll talk a little bit about what OpenAlex is, where it came from, but then why you should use it, really focusing on major features of OpenAlex and how it compares with some of the other databases you might already be using. And then, of course, how you can start using it. So how you can access it, but then a very high-level discussion of the form and function of the database. And I want to do this before the other webinars because what is in the database and how it is structured is really what enables all of the use cases. So some of the other webinars are going to focus on going into the use cases, and this is going to be very high level talking about the metadata structure that enables that. And then again, we'll have a Q&A at the end that won't be recorded, but feel free to put your questions as they come up in the Q&A box. Okay, so scientific knowledge graphs, or SKGs. If you haven't heard that term before, you're familiar with Web of Science, Scopus, Dimensions, but think of these databases that have information on scholarly activity and how they relate to other entities, like which institution authored them, which papers they're citing. We call those SKGs. These are becoming critical infrastructure for research around the world. Research discovery, finding the right research when there's millions of publications each year, scientometric research or research on research, but also increasingly for research intelligence and assessment and evaluation of research by institutions, by governments, by funders, all of these different use cases. You're probably familiar with at least one of the SKGs on this list. Your institution probably has access to one of them at least. But Web of Science, Scopus, Google Scholar here with a question mark because it's a little bit different than the rest. Microsoft Academic Graph, Dimensions, Crossref, and OpenAir. OpenAlex sits firmly in this list of prominent, usable, high-quality SKGs. But really importantly, it's an open, completely open, comprehensive SKG, and that's its major feature. So I'm going to spend a few minutes talking about 4 limitations of the pay-to-view SKGs that really give value to OpenAlex, and dive into those a little bit more so that you know why you would want to use this and what some of the benefits are. So first, subscriptions are costly, results can't be shared, you can't build on some of these other databases, and you inherit their biases or their exclusiveness. I'm going to go into each of these a little bit more. Subscriptions, I probably don't need to say much about, but I think we all know there's increasing pressure on library budgets at universities around the world. And these subscriptions are typically funded by libraries, and the subscriptions go up every year. So increasing budgets while they're getting more expensive, pretty simple to understand there. But also really importantly, systematically, we're excluding less wealthy regions of the world to access to databases like this that could really help them develop their science and technology frameworks and infrastructure. So we see that as really critical. But then a third one that might be less familiar is that even after you subscribe to some of these databases, you still don't have access to the full database. It's limited how much data you can use and get access to, and you have to pay for more. OpenAlex, on the other hand, is completely free, and it enables equitable access to this type of infrastructure around the world. The second point on their or your results can't be shared when you're doing scientific research, you need to be able to show your methodology in a way that someone else could reproduce. And that's sort of a big part of doing science. If you can't share your raw data and your analyses with someone at an institution because they don't have access to that, it sort of limits that reproducibility. But maybe more importantly, more institutions are making decisions based on these databases. And so you need to be able to be transparent around how those decisions are made. And you can do that with OpenAlex. So because it's completely open, anyone can examine and replicate analyses and even do some scenario playing to understand factors that influence decisions by funders, by universities, by rankings, that sort of thing. A really important one here is that you can't build on these products very often, these databases. They usually come with licenses that have restrictions on how you can use them. But not only that, when you have limited access to the database, you can't use it to its full potential. So access to the full database is a challenge. Commercial uses of the data is often not allowed in institutional licenses. You can have challenges with integrating with your own internal and external dashboards. And this is really important because we're starting to recognize that research can't be described by just one type of data. So institutions are bringing in multiple data from different perspectives of research to really get a holistic understanding. And to do that, you need to be able to integrate with other databases. And because this is open, you can do that very easily. And then the final one is, I think, my favorite, the development of derivative tools. As more and more institutions use these databases for important decision makings, you start to see them having specialized needs. So a lot of universities are creating Find a Researcher portal to sort of profile and find researchers at their institution, or find reviewers who aren't in conflict of interest, or research security challenges. All of those can be addressed using this data, but on sort of pay to view SKGs, you have to pay for a separate service to do that based on what exists, the off-the-shelf offerings. Whereas with OpenAlex, you can do that completely free on your end to meet your needs. And so just a final point here that all of the data and codes are under no rights reserved Creative Commons license, and anyone can use them however they want without having to involve lawyers. So we see that as a really major selling point here. But most importantly of these, I think this is really important to spend some time on, is that when you use these other databases, you are inheriting their exclusiveness and their biases. And here are a few of the indexing rules of a couple of these different databases that actually result in biased research analyses. So must have an English abstract. Pretty straightforward. If something is written in French, I'm in Canada, we're bilingual here, but if somebody writes something in French and they don't have an English abstract, it doesn't get indexed. And then as a consequence, it's not part of the research assessment that's happening nationally. So we see this as really important, but not just English and French, all languages around the world. Publication status, so it'll get indexed as a preprint, and then you can sort whether or not you want to accept or look at things that have been only accepted or preprints are available. This was really important during COVID when we couldn't get scientific information fast enough for people to be able to understand what was changing in the research landscape. Dissertations are excluded from some of these databases, and in some fields this is really important because that work doesn't then get written and published in other journals. So we think it's really important that those be included as well. Type of peer review is probably something you're not familiar with, but it has really important consequences. In STEM, there's a sort of general understanding of what peer review should be to be sort of high quality. Some gray area there, but there's a general understanding. In other fields, like law, for instance, a lot of the legal scholarly activities are happening in journals or publication venues that would not meet this same standard because the fields are very different in their standards. And so those aren't getting indexed at all in some of these databases. We think it's really important for you to be able to make the filtering decisions on your own and not rely on what biases are there. Two more quick ones. If a journal has relatively few citations relative to other in the field, sometimes it won't get indexed because it's not seen as a quality journal. But that could also be because it's a very regionally focused journal, and that is still really impactful and important work. We want to make sure you're able to access that information if you're working in that region in particular. But then on the regional component as well, geographical diversity of authors and editors can sometimes keep these journals from being indexed. So Really, the selling point I'm trying to say here is that OpenAlex does not apply indexing criteria on its own, so that you can pick which data to include and which indexing criteria you want to use for your specific analyses. Because of all these things combined, OpenAlex has broader coverage than any other SKG. This table is a little bit outdated now, about a year old, but it's the best one we have now that's accurate to all of them. And you can imagine you can't update one without updating the rest, but we will be updating this on the website as well. But just to give you a sense of the number of works, citations, authors, venues would be like journals or repositories that things are published in, and then institutions. And a couple quick high level, people watching this later can pause and review this in detail, but Web of Science and Scopus, you'll see, have 82 million. I think now they're close to 90 because it's a little outdated, but OpenAlex is 236 million, just to give you a sense of that scale. Another good reference point is MAG, which is Microsoft Academic Graph. That was 204 million. That's what OpenAlex is building off of. So you can see how much has been added since then. Okay, and we get this information because every time a new work is found and indexed, we go through and extract the metadata associated with it, and then enhance it in some ways as well. So this is an example of one of my publications, and you can see sort of the HTML because of the article. It's open access, so you can read it there, where it's published, the authors, their affiliations, some concepts, sort of like subject area. And in some of these other softwares and platforms, you might be used to something like this. The nice part about these concepts, there's 65,000 of them, is it's a multi-layer hierarchy, and each of them is linked to something in Wikipedia that you can then read about. So these aren't random strings of words that are being used to categorize work, but they're actually meant to be meaningful research concepts. And then 10,000 publishers, 102,000 institutions, 243 million works, 32,000 funders, and 91 million authors. You might have noticed on that last page that I showed 243 million authors in OpenAlex. Just this summer, we released a new author disambiguation algorithm that has significantly improved that, and it's reduced it to 91 million authors, finding some of these profiles that should have been merged. So we're really excited about that. But another thing I want to point out, at the bottom here, you'll see that I have an API call that you could copy and paste or type into your web browser, and you can get these updated numbers anytime you want. So you don't have to, email us to find out what's currently indexed. It's there. Okay, when we are indexing information about these publications and these entities, we call them, an entity being an author or a work or an institution, we're getting a lot of metadata about them. And you can go online you can see at the top, docs.openalex.org to get a full list of all of the information. But I did just want to put this up here. Some folks are going to pause it later on, I'm sure, to say that there's some things that you probably weren't expecting. So title, publication date, year, you're probably expecting for work, but APC list price and paid price, for instance, is something that's in here that's not in a lot of the other databases, so that's super valuable. For institution, you can see we've got lat longs, the type of institution it is, but I think really interesting, you can see roles. So imagine University of British Columbia could be an institution, and it is, it's a real one here in Canada. They could also be a publisher, the UBC Press, and they could also be a funder of research, and they do have grants that they fund research for. And so we have those different roles in here so that you can do analyses that way. Authors, probably what you expect, some high-level information, the display name and alternate name variants that have been used, last known institution. For source, also things you're probably expecting, but in addition, the hosting organization and societies of those repositories or those journals, APC price and currency and things like that. And then again, this idea of concepts. So all of these have a name, and it's a name that actually makes sense. It's not a random string of words that has come from all of the papers in a cluster. It's actually something that is relatable, and you can go to Wikipedia and read about it. So really helpful information there. So you're probably wondering how this could be free and be so incredible and powerful. And that's really because it's super cheap to make. There's sort of two main things that are enabling this that I want to talk about. The first is that Microsoft Academic Graph was a really important SKG that Microsoft had put a lot of work developing, and then they decided to sunset it and make that data set publicly available. So really important. This would not have been able to be a reality now without the work that they did that we're building off of. So huge kudos to them on that. And then the second piece is that since they've sunsetted, there's been massive transitions in open access and open science so that more and more work is going through databases where we can scrape that data publicly for free. So to give you an idea, anytime something has a DOI, we're able to extract that metadata. If it's in Crossref, we're able to get the citations. ORCID, we're able to get author profiles. So we're really benefiting both from Microsoft Academic's development and this increasing movement for open science around the world. And these two graphs here, just to show you, on the top, you can see publications that were in Microsoft Academic from 1970 to 2020, it looks like. The red is things that were only in Microsoft Academic, and the blue is only Crossref. And then the purple are things that are in both. And that purple is the area that now we're really capitalizing on moving forward in the future of OpenAlex. And even since that, it's sharply increased. So the graph just below it is the number of publications that were just, or works that were just in Microsoft Academic. And you can see it sharply declined after 2015 as DOIs and ORCIDs and all these things started really picking up. And now that's even more so the case. So that's why we're able to do this in a really cheap and free way. It's important to know that. So I imagine some of you are surprised that we're saying it's both free and better than a lot of these other databases, and you should absolutely start seeing for your particular use cases whether or not that's true and where some of the limitations are. But I did want to say you can go online and read some of the testimonials from people who have been using it and analyzing it in that way. This is just a quick example from the developer of VOS Viewer, which I think is the largest open research analytics platform in the world, but definitely one of them. It's very well known. He says, OpenAlex is of crucial importance for VOS Viewer users because it offers better performance than the other databases and all those criteria. And he sees it as a fundamental building block for an ecosystem of open infrastructure on high quality research analytics. So really, it's ready to start doing really cool analyses on for free. You can go online and read more. And also, if you're somebody who's been using it for a while, feel free to send us a testimonial as well. We have them in the different use cases, but it starts getting really helpful when a librarian has analyzed it for their particular use cases and can describe it to other librarians. So take a look at those. There are limitations. I don't want to come up here and just say that it's amazing and perfect and there's no challenges with it. Every one of these databases, because of the way it's built and its history, has its own limitations. And I want to be very transparent about those with OpenAlex. So the first, we have biases as well in our data. We inherited a lot of data from Microsoft Academic Graph, and we get a lot of the data from Crossref. These are two major sources of where we get our information, but get it from other places as well. If something isn't in one of those and there was a reason why, it's not going to get indexed in OpenAlex. That said, you could see in the coverage when we had 240 million works that it's much broader than most of these. So limited bias there, but some does still exist. The research base is small. What I mean by this is if you go online and you search for papers that have used Web of Science or Scopus or Dimensions in their work, you'll also find some that have compared them, their coverage, their metadata structure, their precision and recall. There's been a lot of research done on those. Doesn't really exist yet for OpenAlex because we're less than 2 years old, but it is rapidly growing and we are very keen to collaborate with researchers around the world. We have a few projects going on at the moment to do this type of analysis. So if you and your research group are interested in doing that, let us know and we're happy to facilitate or answer questions as you go along. Coverage. So some of these databases index patents. OpenAlex does not have any patents in it. It's a really interesting point to say there was recently a researcher who used OpenAlex, an open database, and an open patent database and created linkages between them that you can then go see his code and use that. So that type of thing is certainly possible, but it's not in the database itself right now. And software and data sets do get indexed, and that's of growing importance for a lot of institutions around the world, but it is limited in terms of comparing it to traditional scholarly outputs like publications. Finally, most importantly, stability. OpenAlex is changing monthly. And I just had an exchange with someone yesterday who was very excited and said, I can't keep up with how fast things are improving. And that's great, but it can also be challenging, I understand, as you're starting to ramp these things up. So if you have a particular use case and you're thinking about a project, we'll just happily answer questions around where we're going, and we'll try and make a roadmap more visible so that you can see the direction things are going. But in every situation, it's an improvement. Just to highlight how fast these things are changing, this is OpenAlex history as I see it. In May 2021 is when Microsoft announced that they would be sunsetting Microsoft Academic. And then in December, they discontinued it. OpenAlex beta launched in January of 2022, so less than 2 years ago now. The first user group launched to really start connecting people who were using it, who were starting to explore and probe it, and also exchange information rapidly between us and them so that we can improve the product and offerings. Full text search started in August, the first customer support ticket system in December, and now we offered a premium service in March. I said it's completely free, and that is absolutely true and will remain the case. We found that a lot of people, a lot of users have more advanced needs in terms of our time, and we need to be able to prioritize the ticket service in a way that if somebody does have these larger, more complex needs, we're happy to work with them, but through a premium offering. This premium offering is still a fraction of what all of the other services are, but that's one way that you can get above and beyond if you need more of our time. And then in July 2023, the improved author disambiguation that I mentioned launched. I wasn't even able to put on here that last night we launched the Sustainable Development Goal classification, so that's a really exciting addition, but just to give you a sense of how fast this is all moving. Okay, so hopefully you're excited and you want to start exploring it. So how can you start accessing OpenAlex data? There's 3 ways primarily. The first, you are probably not familiar with if you use Scopus or Web of Science or one of those. You can actually just download a snapshot of the full database. This is really helpful for people who are trying to do their own field normalization and they need the entire database to be able to do that around the world, or they're creating their own research taxonomies based on their federal government, and you need access to all the publications. You can do that. And it's available to download. You can see sort of the link at the top there. You can read and type that in. If you've never used OpenAlex before, or you don't have large scale data analytic capacity, I don't recommend starting with this because it's a massive database and it's complex and it can be very challenging. But if you're equipped and you've got a team who can be able to use it, this is something that institutions around the world are absolutely loving, that you can't get with the other services. Most people at the moment, though, are accessing the data through APIs. Really great documentation online on our website, and you can find all of that very easily. It's so well documented that we have some organizations around the world that have built derivative tools off of our APIs without ever having asked us questions, which is great. That's the kind of thing we want to be seeing. So that is all there. And then the third that I think is most exciting, and that's why we're starting to do this webinar series, is that we're going to be launching the very first web interface or graphic user interface for OpenAlex. And the whole idea here is that many institutions around the world don't have data scientists that can help support their research intelligence needs, and we want them to be able to access this information. So we have an alpha now that we've been playing around with and getting some feedback on, and a beta will be launching very soon. And in the next webinars, I'll actually be doing walkthroughs of the GUI, the graphic user interface, and how to use it for specific use cases. So stay tuned, but really excited about this. It'll be an easy way for you to find the right research, to export the results in a format you need, or even to build API calls, because everything that you do in the graphic user interface, you'll be able to click and say, show me this as an API. And that will help people who have been scared to start APIs really start rolling up their sleeves and get into it as well. So those are sort of the 3 ways you can access it. In the final moments, I want to spend a couple of slides talking about what functions are enabled by the current metadata and content that are in OpenAlex. And this applies to all 3 of the ways that you access the data, because it's just the structure of the database itself. And I think the easiest way to think about that is sort of two different things that you can do. You can subset your analyses and you can analyze the data. So if you imagine of here at the top left, we've got all of the works in OpenAlex. Unlike some of the databases, you can go to immediately start getting insights from that. So you don't have to enter any keywords. You could just start with a full database and say, who are the top institutions, the top country, the top concepts, the top authors, how's it all changing over time? You can do that from the global database, which is really valuable. But you can also apply subsetting logic to this. So if you're used to Web of Science or Scopus, you would use keywords. You can still do that in here, and you can say all of these keywords. You can do and or. We've got Boolean searching in there as well. But you can also add filters or subsets by metadata. So for instance, the year, which institution it's at, which concept it's in, to get a sort of subset of the full database that is exactly what you're looking for, and then do intelligence on that. So in this small subset, who are the top authors? And you can do this with API or the GUI or the snapshot, but let me give you one specific example. So imagine you're looking for only open access journal publications that mention kelp, that have an author from Canada and was funded by NSERC. I put all of this because this is my field. I'm a Canadian kelp ecologist, so I know this very well. And I encourage you all to do the same. When you start using OpenAlex, use a field you know very well so you can get a sense of how it's working. But I just started from all works and I added these different filters on here and it gave me the results. If you can see, there's only 72 results for this very specific field. That doesn't surprise me. It's a very small field, and I think I know everyone in it, but it had everything I was looking for. So that could be the end. You could say, this is what I was looking for. Now this will be a reference list. Maybe NSERC, the funder, wants this list for a particular reason, and that's all they want. Or you could do analyses on that. Some of the common analyses people look at are, what are the top institutions, authors, journals, concepts? Any of the metadata fields that you're wanting to look at, you're able to do this for. And it's the same logic of applying a filter, but you're now grouping by that filter. So if I say institution, I can either, oh, yeah, here we go, sorry. I can either say, show me only from this group the publications at, or the work from University of British Columbia, or I can say, show me all the institutions that have works in this field and rank them by their output. So you can see here, we've got the top 5. UBC, Simon Fraser University, UVic are 3 of the big institutions in Canada because I specified Canada earlier. But you also have the authors, main source concept. So this is the base use case of all research intelligence, and it's enabled in there. I only put the top 5, but you can get way more on there. Of course, I just needed this to be somewhat manageable on the slides. This same logic applies to using APIs. So I want to just quickly say, those filters are the logic layer. We call them filters in API. So you can see at the top, api.openalex.org/works, filter equals an institution with the ROR ID 01CW, QZ, etc. This is now returning all of the works from that institution. And you can see there's 321,000 approximately. So that's a filter you've applied to get that data set. But then you can apply a group by to do those same intelligence analyses. So here I've got that same ROR institution, but I've said now for all of their publications or their works, show me a breakdown by all the different types of open access. And you can see here we've got not open, bronze, green, gold. So that's how that plays out in open in APIs, filter and group by. That's all I have time for today to start getting you hopefully excited to learn more and dive in on some of these use cases. I did want to end with a quick point to say our website has lots of information, and this is another piece that you're going to see evolving a lot over the next few months as we add more for the graphic user interface, and we're going to do more of these webinars. We'll start doing quick hit tutorials. So if there's a specific thing you need to learn how to do that you need to do over and over, let us know, and we can record 3 to 8 minute videos specifically doing just that. But you'll see the website here has documentation, tutorials, a user group, help tickets, and more of these upcoming webinars. The last thing to point your attention to, if you use R now for research analytics, and I think there's a Python library as well, there is a library where you can start doing analyses. It's already been developed. It wasn't developed by us at OpenAlex, but it was developed by somebody else because it's an open data source, and we want people to do that. So feel free to start playing around with that. And just in closing, OpenAlex it's open and it's ready for use, and we really are hoping that people will start using it and start playing around with it. Please reach out to us at any point with any level of feedback. So if you use this form, the openalex.org/feedback, you can report something that isn't working like you thought it would be, something that you'd love to see in the future. You can request a webinar. You can request a meeting with me or Jason or someone else after this to talk about how you can start using it at your institution. Anything you want can go there, and we really look forward to hearing from you. I see those several questions in the Q&A already, so we're going to go ahead and stop the recording and move to that. But thank you for joining us, and thank you for everyone who watched this online.